Today I want to show some of Flownex capabilities to couple to other codes. There are several different ways in which you can couple with Flownex, but today I will show how to couple using our extendibility. The extendibility is a way to add your own libraries of components and solvers to Flownex, and it is such a powerful and generic method of coupling to other codes that you can basically couple to any other code imaginable using this method. So this is kind of two birds with one stone. I'll show a bit about coupling with other codes and also a bit about how the extendibility works. So to couple with a different piece of software, we need some kind of software to couple to. So what I did for that is to write a little program that will be a console program which takes as input two numbers and just calculates the product of those. Here is the little C# program, very simple. Takes two arguments from the command line, converts them to doubles, calculates the product, writes the output. So this is our external software that we will couple to. It's a very simple piece of software but remember this method is generic, so this can show you how to couple to anything from CFD codes, FEM codes, Neutronics calculation codes, anything imaginable. Just to show how this program that I wrote works, just go to our output folder, open a command window and execute it. So let's calculate the product of two numbers. We'll say product with two numbers 10 and 5, and you'll see the result 50 is calculated. So this little exe product is what we will call as our external piece of software from Flownex using the extendibility. So let's move over to the extendibility. Extendibility is the way that you can add your own libraries to Flownex. It is very powerful with giving you the ability to add your own components, solvers, links, and also to customize the environment itself, to add dialogues, buttons, allow or disallow commands, any of those kind of things. Not going to go in depth into all the features of the extendibility. We'll just have a basic overview for our purposes of coupling with other codes. In the extendibility, you can create 5 basic plugin types. The first is components. A component is what you see here in the library. Anything that you can drag and drop on the canvas, that is a component. Ports and links are the way that you link and associate components with each other. So to define linking behavior, you put ports on components and define links that can link between these ports. So the links that you can see on the canvas, they are defined using ports and links. You can write your own of that with extendibility. Tasks are the solvers in Flownex. They're supposed to control the simulation, do the calculations. Typically a component is not a smart piece of the simulation, but it's controlled by a task. So a task can do any kind of calculation, simulation control, things like that. And finally, data references are pieces of data that gets reused through the simulation. So the things that you will typically see here in charts and lookup tables, these are data references. They will be things like fluids, characteristics, lookup tables, things like that. All of these items that you see here that are the basic elements in our extendability can contain properties. So components can have properties, links can have properties, solvers can have properties, data reference can have properties. These properties are the things you see here in the input page. So all of these are properties, and also if you select a solver or a data reference and it lists values here in the input and output window, those are properties. These properties are the way that different libraries communicate with each other and the way that you expose functionality of your components to the rest of the environment. So if you drag and drop something defined as a property onto the canvas, it can be shown in here. You can use anything defined as a property in graphs, reports, design studies, sensitivity analysis studies. So really that's the way to expose your library to the simulation environment. So that was just a quick overview of the different items you get in extendability. What is extremely nice about the extendability in Flownex is how easy it is to use. Extendability is accessed through this little button at the top, which launches the extendability window. The idea of this extendability window is to aid and help in writing the code for you. So for a first time extendability user that doesn't know anything about coding or the API in Flownex and how it should be structured, can really easily get going by using this extendability window. So we will start by creating a new library, and if you see here, a library has created. If you click on it, it lists properties of that library. We can give it a name. Let's give it a name like example coupling, and we'll put it in a solution with the same name. Okay, and since we will be coupling to a piece of software that I just showed you now called product, let's create a component in here that will represent the coupling to that piece of software. Let's call it product. That's the internal code name, and we'll make the display name the same. And we'll add a few properties to it. Let's add 3 double properties to it. There you can see them. One text property. The first property that we'll add is, let's just call it val1, which is the first value. We'll make this property dynamic. Dynamic properties can be changed while a simulation is running, static only before a simulation is running. Result properties are properties that cannot be changed by the user but is changed internally by the solvers. So this will be a dynamic property, which is the first value of your product calculation. Our second property we'll call val2. In the same fashion as the previous one, just don't want to give it a unit. Also make it dynamic, give it a nice display name, and we need to calculate some result with our product, so let's just call this result. It will be a result property, and its display name is also result. And then finally I added a text member variable, and this is to say where the executable is located that we're gonna be calling, the external executable. So we will call this executable name. And then this component on its own can't do anything. we need to add a solver that interacts with the simulation process. We'll just call it coupling task. You can of course use any name you like. And it responds to events from the simulation environment. We're just going to respond to the step event. That's the event that is given when you give one step in a transient simulation. But as you can see, there are loads of events that you can listen to and react to with your solver. Okay, now that everything is set up, we get to the nice part. Now we'll say commit library changes. So what happens in the background is Visual Studio is automated by Flownex. You can see a solution and a project with the correct names was created for you. If you expand that, files are added for you. These files, you'll see them now. The component we call product is added, the coupling task is added, and basically all the code is written for you as we have defined in the extendability dialog. You get a little bit of feedback here, what happened, and everything was successfully built and created for you. Let's move now to the solution, and we can see, just quickly look at the code. If we open our component header file, the component we call product, you will see code has been written for you basically to create your properties named val1, val2, result, executable name, as we defined in the dialog. Important to note these pragmas for the regions. So this is the region where constructors are, this is the region where properties are written, region where methods are written, and the region where your fields are defined. Flownex will, when automating Visual Studio, replace the code within these tags. So don't write your own code in there. We must write our own code outside of these tags. So if you want to add your own code to the header file, just do it outside of these regions and everything is nice and perfect. Here you can see just exactly the same methodology for C++ file. These regions define the areas that is being overwritten from the Visual Studio automation. So if we go back to Flownex, just to show that we actually did something, we can press this reload button. So every time you've changed your library, you must just press the reload button. And when we are done, you will see our new library appearing in Flownex. The extendability libraries are basically just DLLs that get written, and Flownex scans these DLLs and loads the components, solvers and things that you've defined in there, and they become part of your available components to use. So now we see a new library that was created, example coupling with a component called product. We can drag and drop it onto the canvas, and we see some properties that we've defined. If you want to edit this again, you can just say launch extendability window. You can come and add more properties to your component, add more properties, add links in the same fashion. We just now want to open this library, write the code necessary to couple to our external program. You can open this library from the extendability window, but you can also in Windows Explorer open it directly in Visual Studio. Just quickly show you, we are working in this project called example. It's called it's got a folder for all the contents in the project. If we go to solutions, to example coupling, here you will see your solution. This is what you will open in Visual Studio, and you'll see your include files and your source files. As a start, it's easy to get going using the extendability window, but soon you will start writing all the code by hand as soon as you learn how the different parts of it is defined. So usually users end up starting off with the extendability window and then converting to opening the solutions themselves and writing the code by hand. In our task, we need to define something to do when the simulation gives one step forward. What we want to do is we want to call a function in all the product components. So let's define a function, and remember, like I said, do it outside of this regions with the pragmas. We'll define a function called execute. Now header file, and we'll also do the same in our C++ file. And in here we will later on call our external piece of code and actually do some work. Quickly compile it to see we've got no spelling mistakes, everything is good to go. So from our task, we want to get all our product components and we want to call the execute function in there. We've got several helper functions to make it easier for you. I'm going to demonstrate the filter components one now. First, let's make a list. And we will fill this list with all the products that exist in the simulation. We'll do it by calling the filter components function. We give it a type and a list. The type is product, and we want to fill product components. Just need to add our include because that's the way C++ works, and compile to make sure we have no spelling mistakes. Now we can, for every product component in this list, call the execute function. So what will happen now is when step is called, we will find all the components of type product and we will call execute in all of them. If you want to know what types and what functions are available, the easiest way is to use your object browser. You can go to view, object browser, go to our core, and there you can see all the types, their functions, things like that. So that's very handy. There's also a help file included with Flownex that shows all of these types. So in product, we want to call our external little piece of software, and we want to pass it on the command line value 1 and value 2, extract from the standard output the result and assign that result into our result property. So I just want to copy the code to speed up the process. And add some usings. So what we're seeing here is we'll start a new process. We'll use that executable name as the executable that will be called as this process. We have val1 and val2 that we send as arguments on the command line. We don't want to create a window every time, and we want to get the standard output. Then we'll get the standard output that is written by product, and we'll convert that to our result that we give. Try to compile this. And there we go. Just to make this clear, these arguments is the two doubles we'll send, and we'll get the result from the output. For instance, we say product, we'll send the two inputs, for instance 3 and 4, and we'll retrieve that 12 from the standard output. Just build it, everything seems fine, and we will reload our library to reflect the changes. Now we can start testing our library. We can give product some input values. There you see 3 and 4, and we need to tell it where is the executable that it needs to call. So we will just go to where that executable has been built for product. We'll put that in there. Now we've given it the executable name, input values, and we should see a result when we give it a step. There you can see it has calculated the value 12. And we can use other inputs, and it calculates a new result. To see how this happens, we can open our solution again in Visual Studio, and see it happening in our debugger. So we will attach to our Flownex process. And if we change these values again, let's make it something different. We give a step, we'll see execute gets called. We can go through this call stack. Step gets called by the simulation environment, and we in turn call execute on all our product components, and this creates a new process. The process uses our executable name, that is the executable that will get started. We give arguments 8 and 12, what we just now entered, and the process is started. We retrieve the output, and we convert the output to a double. This same mechanism can be used to write to text files, then execute a process, and then read from text files, or to use an automation interface for a different piece of software. So this is just the simplest way, but whichever way any other piece of software supports to receive data and give data out can be automated in a similar way. Okay, so to show this in action, we can maybe just send a little sine wave to our new product calculator. So from our control systems toolbox, we will just get a waveform, give it a nice amplitude, and insert a data transfer link. We'll take the output from our sine wave, that will be one of our input values, and we will basically calculate, let's make that a 5 times the sine value. To show it happening, we can put in a graph and we can drag and drop this property onto the graph. Since this property is defined as a property, we can graph it, we can drag and drop it on the canvas, we can use it in design studies, sensitivity analysis, reporting. So basically it's all part of the environment now. And we can take our value that will be multiplied by 5 and put it in there, and we can run to show it happening. And there you can see our sine wave and the value multiplied by 5 getting calculated by an external application. As simple as that. Hope you found this interesting and see the power in this. With the extendability, you can add your own calculations, your own libraries, your own solvers, but also you can use this functionality to couple to any other piece of software in a very understandable and simple method. There is also training available for the extendability to show you how to use the different parts of it, and as part of this training you will set up a complete library to do some calculations. And that's the end of our extendability and coupling presentation. If you'd like to know more, please contact us for more details. Thank you.